Thank you for the invitation to speak to you today, and thanks everyone for attending. I was given the broad task of covering the topic of designed layouts and sort of where to start with control traffic from a layout point of view, and then also how to integrate precision ag, which can be is a very broad term. So I sort of wear two hats. I'm a director of Precision Agriculture Proprietary Limited, but I'm also in the last 2 years moved on to my wife's family farm, and we're running that. So I thought I might just share the journey of us, my family on our farm, and how we've gone through, and to try and demonstrate some of the principles which can be hopefully applicable to many farmers. So this is us. Sorry, I'll have to look up. So we farm 5,000 acres, about half an hour south of here, predominantly livestock, so we're merinos, and we crop 400 hectares. Rainfall around about 500 mil annual rainfall, thereabouts, so that seems to be declining. The way I see farming is that we want to try and set, and we've heard the words on from some of the presentations already, we want to develop a resilient, robust farming system to account for seasonal variability. It's just the fundamental of what we really need to have to ensure enduring profitability in our farm businesses. So these are sort of the things that we've tried to put in place, and many farmers are. And CTF really is the underlying platform that underpins everything. And to complement that, it's for us it's minimum, not zero, but minimum till, diverse crop rotations, maintaining stubble cover, dealing with soil constraints through lime and gypsum in particular, managing excess surface water through drains, and some targeted fertiliser strategies. We do a lot of work mapping variability of those soil constraints, which I'll touch on later. We also want to look a little bit into, once we've sort of addressed some of those key soil constraints, we've unlocked the potential by dealing with those, then we can sort of shift more into focus on nutrition. And then we want to monitor what we're doing through yield and NDVI, and we do lots of trials just to test what we're doing and to hopefully make sure our actions are working. So, quick slide on some hardware. We're only cropping 400 hectares, so the investments is quite limited. We started farming, share farming out there in 2011 after a very wet summer, and we went straight to control traffic. Used contractors first, but we've been on those same CTF lines now for since 2011, and as you can see, just simple gear. In the slide, we start a paddy by a water. As Matt and Rachel were talking about earlier today, we can get wet in winter, no doubt. We're grey soda sol largely, heavily winter dominated rainfall. So when we're thinking about layouts, we want to start with keeping it with water is in front of mind. So I think about we will get RTK data out of the AutoSteer system and produce an elevation map. And then from there we think about where some drains may need to go, and all the drains that we've got on the farm are just very simple farm-through drains constructed mainly with graders and more recently some scrapers. And then so we think about, well, how do we need to feed water into those drains? And sometimes we take a shorter run, so we'll take an operational efficiency hit to make sure we're pushing water in the right direction. I've done plenty of drainage designs over the years where simply changing direction of run can solve a waterlogging constraint. So really important to get that right from the start. And I know different geographies have different factors to consider, but for us, we're not talking about any contour banks or anything like that. It's just trying to manage that water and then try and keep cover, of course, to protect our soils. Because we do have some quite light textured soils that can blow very easily and haven't seen a lot of damage of water erosion. So that's sort of what our drains look like, and we sow right through them, and you sort of can spray through them and barely slow down. They're okay. Obviously, harvest logistics is another part of it, of course, and thinking about, this is an access track through this paddock. we can get up and back and in a good year and have our 8 tonne, 7 tonne box of header full. So if we're operating without chasers, we use contractors for harvest. Most of the time we've got chaser bins, but we do try and consider. And if we have to put a track in, it'll just be for harvest, and we'll try and use that same harvest track every year. So the single investment, hardware investment we've used for variable rate has been a Landco spreader. It's driven by a Trimble controller, and it's just been a really great investment. We share that with a neighbouring farmer, and we're doing variable rate on all these types of inputs, as you can see. So we start by measuring soils. So for us, we've found that EM38, a conductivity map, and our elevation data coupled together gives us very good insights into how our soil profile changes spatially across the paddocks. So then we'll go through and do some segmented soil testing to understand the base soil properties across our paddocks. So we might be looking at things so understanding buffering indexes, which can help inform decision making on, for example, PBI for phosphorus. Also understanding cation exchange capacity and texture for when trying to determine lime rates and all those types of features. So those stable measurements that aren't really ever going to change again. It's a one-off investment. We'll map our paddock, look at those base properties. We also identify, for us, it's working well, we're identifying our deep sands, and we've actually finding that pretty well all of our deep sand has deep acid issues. So we're essentially mapping our subsoil constraints in the same process, subsoil acidity constraint at the same time. We can also roll those maps straight into doing some VR gypsum. And it can affect an organic carbon and mineralisation rates for nitrogen. There's a relationship there. We haven't used it to a great degree yet, but it sits there as an opportunity, I believe. So we're going to do this testing, and I'll just flick through the result, flick across that. But we'll do zonal tests in these different regions and just get an idea, a snapshot of what sort of properties we're dealing with. So that's our sort of profile mapping work that we would do, and then we would go over the top with a grid. So we've been using a 2-hectare grid and splitting the paddocks up into that 2-hectare basis, and then doing some soil testing. We initially started by focusing on measuring pH and doing VR lime, but the beauty of using lab quality, so we literally collect a 0 to 10 soil test and send off to a lab. We're using APAL as our laboratory at the moment. We can get a whole range of different things tested. So pH and phosphorus are the main two, but we're also increasingly doing exchangeable cations, and that's going to assist us hopefully, particularly with gypsum. We're doing some work this year with the Whitlock catchment group on that. So we would drive across the paddock, collect these, a composite test for each 2-hectare grid, into a bag, off to the lab, and then produce these sort of surface maps. And this is an example of some of the maps that we've generated, and it's been fascinating to see how variable the maps are and how the different nutrient maps and pH maps often have no correlation to one another. They're quite independent, and a lot of the paddocks we are doing this on are converting pasture paddocks into a cropping phase, and so it may be a little bit different on other farms, but we're seeing enormous variability and opportunities on every single paddock we go into for VR strategies. So lime, gypsum and drains and setting our AB lines, that slide there sort of represents a starting point of every single paddock we're entering into a cropping phase. And for me, I just want to tick, in my mind, I'm hoping to tick the box. I'm hoping I've got a robust soil farming system in place. Hopefully I'm addressing sodicity, acidity, surface water issues, and I can enter a cropping phase with some sort of confidence that they're not going to be limiting yield, and then I can focus more on nutrition. So that's how I suppose my background was always in understanding and working with farmers on healthy soils, and I think by going down this path, we're trying to promote that sort of healthy platform. There are plenty of other ways to map farms and constraints, and this is one of our other paddocks, and this was actually before I had actually gone down the path and did some conductivity mapping. We were seeing patterns in yield maps and NDVI, particularly in our canola phase, and we investigated these areas, and we mapped, essentially we were able to map our subsoil acidity issues. So we can see here lower biomass, did some testing through here, and you can see the results. So once we hit around about 25 centimetre, we normally touch clay in this zone through here. And once we get into our clays, our pH lifts quite significantly, up to sort of pH of at least sort of 4.8. And yeah, you can see the results there. So we've used those maps to build via lime programs. And I've been doing some work in Western Australia and some work on coupling gypsum with lime to try and improve movement. Not sure if the science is right. We have gone down that path and we've put some gypsum out on those zones as well. Potassium may play another role of trying to move that lime down further. So we've actually got a potash trial as well. But interestingly, we've been doing some work here on subsoil amelioration. So we're incorporating lime and organic matter into the subsoil. This is a partnership with Southern Farming Systems and New South Wales Government. And so that'll be interesting sort of demonstration, replicated demonstration trial. Lucerne pellets ripped down to 30 centimetres was the best result in the lupin in this first phase of the lupin crop. We'll be into wheat next year, so we'll track that through. On-farm trials, Michael Fitzner commented earlier how easy trials are, and we do lots of trials, and one of the focuses for this year was potash. We put a lot of strips out this year, and so we will look at, continue to look at potash, because when we test in the soil it says it's low, but we've found it hard to get the yield response to it, so we'll continue to work on that. So in summary, in my opinion, it's worthwhile getting the right data. Start with a good platform that works well. You want to get those A/B lines set right and hopefully never change them, of course. In all the work we've done with precision ag, and we work with lots of farmers up and down the east coast, the best return on investments have always been around when we've improved soil constraints or dealt with soil constraints. And so that's the focus there. I'm trying to unlock potential rather than have the mindset of sort of minimising costs. We really just want to try and unlock that yield potential. Really important that when you are building your application rates, your variable rate strategies, you're using the right data. So I see a lot of people using a whole range of different data sets, which could be, they might be relying on loose correlations. With the detailed work, it's more expensive, but with the detailed soil mapping work that we've been using, I've just got confidence as a grower to when we pull the trigger to implement it, and on-farm trials and working in local communities, all the usual things to try and fast-track our learning, because the more we learn, the more we realise we know very little, I believe. So that's my summary. Thank you.